Stokes error. My total net force is what we calculated in part C. This is also an example of a problem where part A was finding the weight, so that was just straight up, you needed to do that. Part B was the acceleration. And you needed that in order to do part C, and you needed that and the first part in order to do part D. If you know how to do part D, for example, but you don't know how to do these, just make up a number for these and solve it. Show me you know how to solve this given that stuff. And that way I'll take off for that, but you'll get full credit for that, assuming it corresponds to what numbers you made up.
Okay.
If you make up a number, please do not choose 0 as that number.
Just cancel it all out.
Yeah.
It doesn't exist.
The weight is 0. If you do that, you might get an OS written next to it, which means oversimplified. Other questions on this or any other problems? Okay.
It's based on the first one that I did.
Okay.
The question is, if there is friction between the box and the ground, then what would the magnitude and direction of the friction be for the box to be in equilibrium?
Okay. Read that again, because
Okay.
my interpretation was there's a
If there
problem.
is friction between the box and the ground,
Okay.
then what would the magnitude and direction of the friction be for the box to be in equilibrium?
Okay. So if I have acceleration acting that way, well, first off, I want to be in equilibrium, I want the total force to be 0. So if I have 12 newtons acting that way, which way, and 10 newtons acting this way, what force would I need in order to balance it out? Yeah, so 2 newtons this way would balance it out. So that would be the direction and the magnitude of the friction. Is that what you're asking? That was the ask? Okay.
So it would be 2 to the right.
Yes, or given the finding positive to the right, you can just say positive 2 newtons.
Because friction is always opposite of force.
No, it's opposite the desired direction of movement. So it will not achieve equilibrium as long as the velocity's in that direction. So if it's just, this is being dragged across the ground, then yeah, it's gonna have to wait to slow down and then start moving in that direction for friction to act this way. Other questions? All right. I know the reason you weren't asking questions just then. 1, you understand everything, and 2, you're just anxious to get to momentum. So let's talk about momentum.